Hi, this is Vignesh, and this is a video on how to use Dijkstra's algorithm. So Dijkstra's algorithm is used to find the shortest distance from a start node A to any other node in a graph. Now, in this example below, we have 5 nodes connected by a series of edges that have weights on them. And these weights can either represent the distance between the two nodes, or we can also have them represent the time it takes to get from one node to another. For this example that we're going to look at, we can assume these will be distances. So the first thing we do to run Dijkstra's algorithm is to set up these boxes at each of the nodes. And what we do with these boxes is basically keep track of what is the minimum weight to get to that point, and what was the previous node that we were at before we got to that point. So once we've set this up, we can start going through the process. And first off, we select our start node. So if we're starting from A, we can set the weight, the minimum weight at A to be 0, and the previous node to be blank, because this is our starting point. And at A, we basically look at the outgoing edges. So we have A to B with weight 2 and A to C with weight 8. And we can update the information in the boxes at B and C. So at B, we would be updating the minimum weight to be +2. And the previous node would be A, because that's where we came from. Likewise, at C, the weight would be 8, and the previous node we came from would be A. At this point, we have one node that's already been selected, which is node A in light blue. And we have 2 nodes that have this minimum weight information, but we haven't selected what comes next in this process. So because Dijkstra's algorithm is a greedy algorithm, what we want to do next is to evaluate which node amongst the unselected nodes has the least minimum weight. So comparing 2 against 8, node B has lower minimum weight, so that one gets selected next. And then it's a case of repeating what we've done. So from node B, we look at the outgoing edges. So we have B to C with weight 5, B to D with weight 6. So starting from this weight of 2 now, 2 plus 5 would be a weight of 7. And this is going to be lower than what we already had at C. So we can update the minimum weight information to be 7 now, and the previous node as being node B instead of A. And then B to D is going to be 2 plus 6, which would be 8, and the previous node is going to be B. We compare the least weights again amongst the unselected nodes. We would pick node C. We look at the outgoing edges from C. So 7 plus 2 here is going to be 9 at node E. And 7 plus 3 is going to be 10 at B. But because this is more than what we already have in that box, there's no need to update that information. So we just update the information at E. So looking at the least weights again, we have 8 and 9. We pick 8. And then we look at the outgoing edges. So 8 plus 2 would be 10. And because 10 is more than the least weight we have, there's no need to update this box. And finally, we can select E. So this is the information that we get once we've completed Dijkstra's algorithm. So now if someone asks us the question, how do we get from node A to node E? We can basically trace back our steps from the destination node. So from node E, the previous node was node C. From C, the previous node was node B. From B, the previous node was node A. So we get from A to E by going down this path A, B, C, E, and the minimum weight to do this is a weight of 9. So this is how we use Dijkstra's algorithm to get the shortest path between 2 nodes.